On the bench this morning, we have a Motorola Quantar, the venerable Motorola Quantar. This is a P25 repeater slash base station. It's been around for about 30 years, I'd say now, and is a rock-solid workhorse of a repeater. You'll see these things all over the place. Tons of people using them for ham radio repeaters. Lots of people still using them in commercial service. Many trunk systems use these things. Almost every Motorola P25 trunk system before they introduced the new GTR 8000 was using these guys. So fair to say, they've been around the block. This particular Quantar comes to us from W9YB, the Purdue University Amateur Radio Club up there in West Lafayette. I was actually a member of the club when we picked this thing up. We got it from a police department in a Chicago suburb. We actually bought it out of the back of a police car trunk and threw it up at the club, got it running, and it was our P25 workhorse for, 5 or 6 years. Recently, it developed an issue. We'll get into what that issue is in a little bit, but they gave it to me and said, hey, can you take a look at this and try and fix it? And I said, sure, what the heck? Might even make an interesting video. So before I dive into the troubleshooting, I figured I'd just give a quick overview of what this thing is. Like I said, this is a Motorola Quantar. It is an analog and P25 repeater and base station. It can be used as either. It's 5U, rack mountable, and modular, so all of the individual modules you see there slot into a common backplane, and you can swap modules in and out as they fail. You don't have to take the whole thing apart, and it's really a slick system, all things said. So just a real quick rundown of what each module is in this particular station. On the far right here, we have the receiver. That is, as the name implies, the receiver for the unit. It has a pre-selector on the front here. You'll notice only 3 of the 5 slugs are actually populated on this one. That identifies it as a UHF receiver. The VHF receivers, all 5 of those slugs would be populated, and then on the 800 megahertz and the 900 megahertz repeaters, there's actually no pre-selector and no tuning slugs, and there's just a blank plate there instead of holes for the slugs. To the left of that, the blank plate there, you can do several things in that slot. There was an option for a second receiver, so you can actually have dual receivers. You could have a ultra-high stability oscillator. I believe it's an oven oscillator that you could slot in there for a frequency reference. But most stations you see just have that slot blanked off. Moving on to the unit labeled control, that is the SCM, the station control module. That is the brains of the repeater. That's what you program when you're changing frequencies, tones, modes, things like that. That's what you interface to when you're doing things like repeater linking, and that's where most of the firmware is also held for the repeater. To the left of that is the power supply. That should be fairly self-explanatory. It is the power supply for the entire repeater. Provides, I think, 28 volts, 5 volts, a couple other weird voltages for all the various analog and digital things that go on inside this thing. The power supply is also one of the things that seems to be failing the most among units out in the field. I guess they had a run of power supplies not made to the best standards, and they like to blow up inside, so if you have a fleet of Quantars, highly recommend you just keep on hand a couple spare power supplies. I actually have a couple on hand here, just because apparently they're not the most robust things in the world. To the left of the power supply, the exciter, as it's labeled, that is what actually generates the transmitted modulation, so be it analog or P25. That is actually the module that's having problems in this particular unit, and like I said, we'll dive into that a little bit more in just a sec here. And to the left of that is the power amplifier. That is what takes the generated modulation from the exciter, amplifies it up to, in this case, 100 watts, and then puts it out the transmit antenna connector. There's 2 types of power amplifiers you can get. There's 25 watt and 100 watt versions. It's not easy to tell which one you have by looking just at the front panel, but if you slide it out of the rack, you'll see the 100 watt module has very large heatsink fins, and the 25 watt module is substantially smaller. The 25 watt PA was actually used as a pre-driver for, I think it's a 200 watt PA that would have been rack mounted above or below this thing, and that was actually what they called the Quantro repeater. It was just a higher power version of the Quantar. I think they did a similar thing for the nucleus stations, which were transmit-only paging stations for transmitting paging tones. They also had a 25 watt amplifier, and I think that was, again, a 200 or 250 watt power amplifier that was a separate rack mount unit. Anyway, without further ado, I'm going to go ahead and power this thing on and show you what the problem is. Yeah, it helps if you plug it in. So when you first power the thing on, the fans are going to whir up. You're going to see a lot of lights. The important ones to look at are the lights on the station control module. Once everything is all booted up and ready to go, you will see station on lit up, and you shouldn't see any other red lights. So we'll give it a second here. It's going to go through a couple other self-tests. You'll see a couple more lights flash. And eventually you should see station fail, turn off, station on, turn on, and the station will be running. And so here's the problem. Take a look at the exciter. Notice how all of the LEDs are still lit. That is not what's supposed to be happening. Normally you should be seeing just a single green light. That TX lock light should be on, which tells you that the TX VCO is locked and it's ready to go. In this case, all 4 LEDs are still lit, and that actually means, as far as I can tell at least, that the processor inside of the exciter just isn't booting up properly at all. One of the first things it does on boot is turns off all of those LEDs. So we're going to have to dig in a little bit, see what's going on there, and see if we can't figure out a fix. So here we have the exciter pulled out of the chassis and sitting here on the slightly cleaner workbench. We're going to pop this cover off, take a peek inside, see if there's anything glaringly obvious wrong with it, and if not, maybe dig a little deeper, probe around a little bit, and see if we can't figure out what's going on. So, without further ado, let's go ahead and pop this cover off. So inside we have the beautiful PCB with 4 shielding cans that are hiding most of the interesting stuff. So we'll go ahead and pop those off real quick. And here we are. With the 4 cans removed, you can see the absolutely beautiful job that the Motorola engineers did laying out this PCB. The section we're interested in is in the top right here. That's what they call the microprocessor circuitry section. It's got the Motorola 68HC11 microcontroller there with a associated flash firmware chip sitting next to it. The rest of the chips in there are just some glue logic, things of that nature to handle switching of the data lines between the various other chips that are present here. And my money is on something in that section being wrong. I'm pretty sure these other 3 sections here are fine. They are all kind of the analog side of things, and this exciter was working fine up until it failed. And the way it's failed, not even communicating at all to the SCM, makes me think that probably the analog side is perfectly fine, and our problem lies here in the digital domain. So here are the schematics for the UHF exciter. This comes from the Quantar service manual. This particular PDF I actually downloaded from Brian Fields, W9CR, his website. He went through all the effort to gather up all the individual documents that make up the Quantar service manual, scanned them, compiled them together, ran it through OCR, and uploaded it to his wiki for anybody to download. So if you are looking for this, it is on his wiki at wiki.w9cr.net. And that wiki also has a bunch of fantastic information on the Quantar, on other Motorola radios, and other general radio-related things. So highly, highly recommend that you check that out. So anyway, looking at the schematic here, the first thing we got to figure out is how to power the board up when it's out of the chassis. So looking at this schematic, the left side is where all your inputs are, and the right side is where all the outputs are. All the inputs and outputs, except for the antenna connector, go through that rear card edge connector that slots into the backplane. But they just broke it up to inputs and outputs on 2 separate sides here to keep it a little more, clean. Looking at the bottom left here, we see we have 2 input voltages. So we have 14.2 volts and 5 volts. And those are the 2 voltages that we're going to have to feed into this board to get it to power up. So I am just going to solder on some bodge wires, probably right here and right here on these 2 decoupling capacitors, and hook those up to some bench power supplies, set a current limit, probably 200 or 300 milliamps, just enough to get the thing to power up, and not enough to smoke anything if something shorted or if I did something stupid. And that should be enough to at least get the board powered up. The other thing I want to look at here is the reset line that's right above there. So the station control module, as it's labeled there, is able to send a reset pulse to the board to reset everything and get it to power up. I want to check the output of this last NAND gate here. you can see where this big block of text is. This is the master reset line for all the chips in the digital section. So I want to take a look at that, see if it's actually resetting properly. As the text says there, when you apply power, after about 1.5 seconds, you should see this line go from low to high, and all the chips start up at that point. So I want to get everything hooked up, get power applied, get a scope probe on that line, and see if it's doing what it's supposed to be doing. So here's the setup on the bench. I am feeding in 14.2 volts through the yellow wire here and 5 volts through the red wire here. Those are going into those 2 ferrite beads that I mentioned on the schematic. I've also got an oscilloscope probe here soldered to the output of that NAND gate on pin 8 of that chip, U3704. And according to the schematic, about 1.5 seconds or so after we apply power, we should see the output of that NAND gate go from 0 volts to 5 volts. So the station comes out of reset and goes into normal operation. So on the oscilloscope over there, we should see that trace, which is at 0 volts right now, go up to 5 volts. So without further ado, I'm going to go ahead and turn on both my power supplies here, and we will see what happens. So you can't really see it on the camera, but the 4 LEDs are lit up on the exciter now. However, nothing happened on the oscilloscope trace there. So something appears to be wrong with that reset line. I'm going to go ahead and take another look at the schematic, make sure I'm not missing something obvious, and if not, we will continue on. All right, well, that should have been obvious, and I'm wondering if anybody actually caught it when we were looking at the schematic previously. This is the external reset line from the station control module, and you'll notice it just goes straight into this first NAND gate without any type of pull-up or pull-down resistor. So this line is just floating right now, and in order for the station to not be continuously in reset, we need to tie that high to 5 volts. Which is what the station control module, I'm assuming, does during a normal boot up procedure. So I'm just going to take a jumper and solder it over here and go down to our 5 volt rail, and we should be good at that point, and we should see that reset line go high like it's supposed to. So let's go back over to the bench, give that a shot, and hopefully that was it. All right, I've got that reset line tied to 5 volts, so we're going to do the same exact thing again, and hopefully we get a little bit better result this time. So again, watch the reset line over on the oscilloscope. We should see that go up to 5 volts a couple seconds after I apply power. So here we go. And look at that. We have a nice 5 volts on the reset line, so theoretically at least, that means all the reset circuitry is working properly. It behaved almost exactly like it said it would in the schematic. So I think we're going to need to dig a little bit deeper, but while we've got it powered on, we might as well check voltages, as is the golden rule with any electronics troubleshooting. So I will go ahead and throw my multimeter into volts, ground out this probe somewhere, maybe on one of the shields here. And we'll check a couple of these logic gates in here and see if we can't find one that is not powering up properly. Let's go ahead and check the EEPROM. That would be this pin here. Hold on. I'm reading 2.2 volts there. Well, I'll have to make sure that's actually the VCC pin for that EEPROM. It might not be. And I'll also have to pull up the pin out for that 68HC11 to make sure that we're probing the right thing on that side. But so far, everything looks like it's powering up properly. So I did confirm that the pin I was probing on the EEPROM was the VCC pin, and I noticed when I was pressing on it with the probe, I could get it to read either 2.2 volts or 5 volts. So I pulled out that EEPROM chip and reseated it and powered on the station a couple more times, and the very last time I powered it on, I got a very interesting result. So you're looking at the front panel LEDs there, and you'll notice that the PA low and PA fail LEDs are alternating and flashing very quickly. I've never seen that before. I don't think that that's a documented error code of any kind. What I actually think is happening is, if you recall, it was when we looked in the schematic, the latching chip for those LED outputs is actually driven by the same data bus that drives the that reads from the firmware chip. So I'm wondering if maybe the data clocking is getting routed to those LEDs mistakenly, or the microcontroller is, for whatever reason, clocking out bogus data onto the LED pins. So something very strange is going on there. I will continue poking around. So as it turns out, poking around might actually be the perfect troubleshooting method here. So watch the LEDs down there in the corner as I just kind of jiggle the EEPROM chip here in its socket. Wow, all the lights went out that time. Yeah, something's definitely not right over here in the microprocessor section. I should not be able to totally change the behavior of what the MCU is doing just by touching the top of the firmware chip there. So something very concerning is going on. I'm going to give it another power cycle here. Okay, so we have all the LEDs on. If I touch the EEPROM chip, oh, now we're not getting anything like what we were just getting. That's very, very strange. I'm going to go ahead while it's in this state and probe the voltage on the power supply pin again. Let's see. 2.2. So it's reading 2.2 right now. Let's see if I push harder. No? Okay, now it's really stuck at... Nope, now there it's at 5, but our LEDs are the same, so... Oh, very, very curious. I do not know what to think about that at all. Alright, tell you what, I'm going to pop that firmware chip out of there and shove some deoxit into that socket and see if maybe there might just be some corrosion or some debris in there that's preventing the firmware from being read properly. So I've got those EEPROM pins nice and soaked in deoxit, and while I'm letting that sit, I figured I might as well check continuity between the EEPROM pin and then the socket pad on the PCB there. So I'm just going to go through all these pins. I've got my multimeter in continuity mode. Not sure if you can hear that or not. And we're just going to check and see if there actually is continuity where there should be. We might have found one. Yeah, that appears to be not at all making contact. That is interesting. Ooh, ooh, wait. Okay. That one's questionable. I have to push pretty hard before I get a continuity beep, so... Moving on. That one's also questionable. I have to again push pretty hard before I get continuity. Same for that one. And same for that one. That's the VCC pin, the last one. So we might still have some issues here. We'll move on to the other side, and I'll try not to totally block the view for you guys. Get that wire out of the way. Alright, so all the pins on that side seem fine, so I'm going to come back, I'm going to push that in nice and tight there, and I'm going to try those last 4 pins on this side again and see if maybe they're any better or if they're doing the same thing. So yeah, I can touch the socket and make good continuity, but and see, now it's fine, but earlier I would touch the side of the pin on the chip there and was not getting continuity, so. And that one's fine. That one required a little jostling. And that one also required a little jostling. I'm going to continue playing with this a little bit, maybe just reseat the chip a couple more times, because I think there's still an issue with making good contact on that EEPROM chip, and that would definitely cause the issues that we've been seeing. Alright, so I got a little bit more aggressive with the troubleshooting. I actually went in and reflowed all 28 pins on that dip socket. You can see they're a little bit shinier now. That was just in case there was, you know, a cracked solder joint or something that I couldn't see or wasn't really apparent. But I'm probing it again here, and I still am not a big fan of how it's behaving, especially this first pin here, the pin 28, which is VCC. You know, I don't get good contact unless I really push on that. Like, I gotta go all the way down. I'm touching the socket right there, and I've got good contact, but as soon as I come up onto the pin, I've got nothing. But if I push really hard over, then I get contact, but I have to physically push that pin into the body of the chip there in order for it to make contact. So I wouldn't be surprised if that's not the main problem. That's still a big problem. So I think the next step here is I'm going to order a new dip socket and desolder the old one and put the new one in. I should be able to get one in a couple days, and we'll go ahead and solder that in when it gets in, and hopefully that solves the issue. So I will see you guys in part 2 of this video, which will be desoldering the old dip socket and soldering the new one in.